What did somebody get from yesterday's?
12.85.
12.85.
I might have got one. I was going to garage.
12.6. Seconded. More 12.6s? Was it like, no, it wouldn't have been exact because you probably had the trig functions with lots of decimals. 12.45?
4 pi.
Oh, 645.
No, 4 pi.
Okay, we're not going with real answers here. There's no way your rectangle's got 4 pi. Did you like integrate it or something?
We just couldn't simplify it down like for every single rectangle.
I suppose the angles were probably good enough where the answers weren't bad.
Because it was like root 2 over 2 plus 2 times pi.
Yeah, I suppose multiplied by pi over 4. So what was it, 4 pi?
Yeah.
Okay.
4 pi is 4.6.
Yeah, 4.566.
Okay. So it sounds like most people got that. Okay, 12.85, I'm going to guess is something went slightly wrong, maybe on one of the rectangles. The other issue you might have ran into, which you probably should have noticed quickly, is if you had it in degree mode, your answers probably would have been different. Because a lot of you are in physics, and so your calculator would be in degree mode already, and so your answers would all be wrong. Maybe you didn't even notice it or think of it. Okay. The actual correct answer, non-rounding, was 12.566. Now, you weren't supposed to get 12.566. But if you guys remember, when we were doing it, we kind of thought that the estimate should be pretty close because we had some overestimates, some underestimates, and they looked like they might kind of balance each other out. So 12.6 is actually pretty fantastic considering this is more exact. And I didn't even go through to work out what the answer is non-decimal. I wasn't expecting non-decimal answers. Okay, so it seemed like it went well though for most everybody?
Yeah.
All right. Anything in particular while you were doing it that maybe wasn't that easy? Or that took you maybe time to get used to? Most likely once you figure out the pattern, then it kind of just goes quickly from there. Okay, well, I thought what we should do, the next section feels like a decent jump from this one. And since we didn't have the packets yesterday and we basically only did like 2 questions the whole hour, I thought it would be good for us to do some questions together from the packet and then kind of give you some time to work today, which we normally don't get. We haven't really figured out how we're going to incorporate win time yet. So the purpose of win time is we're not supposed to teach like 2 lessons in one day, even though it's like an 80-minute class, so it's kind of like a class and a half. But we're not supposed to teach 2 lessons, and that really cuts out a lot of time for us. So we're trying to figure out a good way to schedule the rest of the trimester so that we can still finish as much as possible, if not all of it, before the AP test. Do know that if we don't finish, you still easily know enough to get a 5 on the test. What most people don't get is each AP test is graded different. So like past AP tests you've taken aren't graded the same as the Calc one. The Calc one, traditionally, if you get about a 60%, that's a 5. Because they take everybody's scores and they put them together, and then, certain percentage get 5s and et cetera. So roughly 60% of the questions being correct is a 5, and then it just kind of goes down from there. I mean, obviously you get a 1 just for putting your name on it, but like I know some people were worried, about how they would do on the AP test if we weren't able to finish this year from all the various things going on. Plus, we've been going slower because a lot of you didn't learn as much in pre-calc as you needed to because of distance learning. But no matter where we get to, you guys will know enough to get a 5. So it's not necessarily in terms of how well you can do on the AP test. It's just satisfaction of being able to finish. So AP scores separate. You can still do fantastic on that, no matter what. You already know enough to get a 3 on the AP test. So half of the AP test is derivatives and half is integrals. We've already done derivatives. So think about that. If you get 50% on the test, you possibly get a 4. And we haven't even done the other half. So you guys will do well on the AP test. That's a totally separate concern than, where we get to. Okay, so let's look at number 1. It says Riemann sum approximation with n partitions to the integral from a to b of f of x dx. Now, I kind of partially wrote this down yesterday, like very little. And I told you that was the same thing as adding up an infinite number of rectangles. Let's see, who should we go with first? I need to pick people's names I need to learn. Kate. I already forgot which Kate. Okay, Kate. That's why we need a seating chart, so I can get that down. Kate, is that a left or right-hand sum?
Left.
Okay. Any reason you think so?
Because the function, it touches the left side. The left side of the rectangle touches the function.
That's a great explanation. So if you look at this first rectangle, you've got left side, right side. The left-hand side of that rectangle is touching the function, so the left-hand side of the rectangle is what dictates the height of the rectangle. So absolutely, left. Excellent job. Okay, Kate, do you want to pick somebody else?
Lauren.
But I already know Lauren. I suppose you don't know who I don't know now. Okay, Lauren, do you know what the A, B, N, and delta X is? I didn't really distinctly talk about those letters.
I don't think I know what N is.
Okay, how about A and B? We'll start with that.
I would guess A is 0 and B is 6.
Perfect, because this graph goes from 0 to 6. A and B generally represent where it begins and ends. If you look at this integral that was written there, these numbers on the integral represent where it begins, where it ends. Okay, good. N represents the number of rectangles.
Okay.
So 6 rectangles. And if you want to write a little note to yourself if you want, need to know what this number stands for, do that. Delta X. Does anybody, the notation is probably more common in your science classes. What did the delta X stand for in your science classes?
Change.
Okay, so it's kind of the same here. It represents how much does the X value change from one partition to another. So delta X represents the width of the rectangle. So in this case, 0 to 6 divided by 6 rectangles. So that we kind of did this in our notes yesterday. Just delta X wasn't the notation we used. So this would be 1. So each rectangle is 1 width. Okay, we didn't necessarily need to know that equation. We were just trying to answer things from this to make sure we know how things are set up. Okay, Lauren, is there somebody you want to call in?
Do I have to?
No.
Okay. No, there is not anyone else. I can call on.
Maybe I should have just said Lauren, call in somebody. Jackson. Right, Jackson, okay. Jackson, if we're looking at that picture, it says, it's supposed to say use the graph below to estimate. The integral from negative 10 to 15 of f of x dx. What are we actually finding if you see that, that notation written down? What is it telling us to find?
It's the area
True. Of what?
of the function.
I'm not sure how to word this differently. I mean, you're not wrong. You're just not very specific. So we are trying to estimate the area underneath the curve or in between the curve and the x-axis from negative 10 to 15. So if I were to draw it badly, if I were to draw it badly like I am, we'll just call that good. This is what we're trying to find. We're trying to estimate that answer. Now, technically in the future, if you see this notation represents the exact area, not an estimate. If you're told to use Riemann sums or to use 6 rectangles to estimate, that's estimating. This notation generally represents the exact answer. Now, should we do this one together? Would that be beneficial? Yes? Okay, let's pick the hardest of the 3 methods. Let's use midpoint. I feel, whoa, what did happen? I clicked the button on the pen on accident. Whoa, what the heck? Can I change my words into text?
I thought you could. Isn't that a thing?
Oh, except it thinks I wrote 6 yen. That's interesting. How about that? Huh. Weird. Can I undo it? Oh, now I screwed it up. Oh well.
Just say Control Z. Let's try and do it. Like on your keyboard.
I got a button on the bottom I forgot about. Okay, weird. Totally nothing to do with what we're doing. Let's use the midpoint method. Only because I think most of you are probably most uncomfortable doing the midpoint method. Left and right seems to make more sense. So midpoint method, Andy, how many rectangles should we use? 5? No, that's way too easy. Did you say 5 because there are 5 squares? Yeah, we're definitely not doing that. Give me a number that's not compatible with 5.
6.
Sure. 6 rectangles. We're already going from negative 10 to 15 because it said so. Okay, if you want to draw this, go for it. I think we should probably figure some stuff out first. Okay, excellent job. Andy, call on somebody. See, I'm learning. Don't ask, just tell. Call on somebody else. It's not a mean thing to have call on somebody to answer. Ashoka won't be mad at you.
Oh, yeah, Teddy.
Wow. Teddy, I felt like that. Yeah, I felt like that was a lot of disrespect right there.
That's fine, right back.
Okay, Teddy, what I was hoping you could help me do. How wide is each interval going to be if we're going from negative 10 to 15 with 6 rectangles? And I can help guide you if you want to. I feel like you're just throwing numbers out there.
25 cents.
Where are you getting that from? It looks like people around you are just like whispering things. I see. Okay, so for us to figure it out, we need to do b minus a divided by n.
Oh, it's B minus.
Now, if you don't want to memorize this, that's fine. But you're going to need to figure out how wide the entire thing is. That's what b minus a is. So 15 minus negative 10. And some of you could have figured that out by just looking at the picture. It has a width of 25 divided by 6 rectangles. Suppose I should use the right notation. Okay. If you want to translate that to decimals, you certainly can. So because a lot of this is estimating, decimals aren't a big deal. When we move past later and we're not estimating, then decimals aren't really favored upon. But for this, the whole answer generally is going to be a decimal anyway. So if you want to make 25/6 into, what is that, 4 1/6, 4,
Yeah, it's 416 repeating.
4.167. That's a bad 7, but it's a 7. So generally AP likes 3 decimal places for final answers, or they consider 3 decimal places to be the same as exact. I know some of you guys have done sig figs a lot. Probably grown at the name of it, I know. For our final answer to be accurate, we should use more than 3 decimal places in the problem so that the final answer is accurate. Now, I don't want to mess with that right now because I feel like you probably got enough going on. So I'm not going to worry about adding decimals on top of this just for accuracy. I want to make sure that we're just doing the correct thing. Oh yeah, we were on Teddy. Teddy, yeah, I do know who you're going to call on, but I'll let you dictate it.
I suck.
Yeah, put some force in it. Okay.
Yeah.
Yeah.
Actually, no. I'll call her no.
Look at that. Played the reverse Uno card.
Yeah, Snake died me.
Okay, Renan, where do I go from here?
So you gotta find the midpoint.
Sure. Sounds good.
Gotta find the midpoint. Like the formula.
Ooh, what's the formula?
The midpoint formula.
I kind of want to see how long you're going to make up stuff. Okay, wow.
You were sleeping?
We just like estimate. It feels weird when it's estimated.
Okay, our first interval starts at -10. Where would our first interval end? How do you find where it ends?
No, not.
You know, Kaden, you can't just like tell everybody all the answers.
We know the answer.
Yeah, we know you know the answers. Okay, yes, you're going to add 4.167 on to -10, which will be roughly here.
Okay.
Okay, so -10 plus 4.167. I'm assuming somebody already did that. What did you get on the calculator? -5.83. All right, I'll go with that. Okay, Renan, what's this magical midpoint formula you were talking about?
I don't know it, but I just know there's a midpoint formula.
There is.
Yeah.
How do you find the middle of two things?
The formula.
It's the same as average.
Oh yeah, it's like f of b minus f of a.
You add them together and divide by 2. So the midpoint is the exact same thing as finding the average. So we're going to add -10 and -5.83 and then divide by 2. I should zoom in. I don't have nearly enough room to write anything up here. It's not a lot bigger. Okay, so -15.83 divided by 2, it's got to be like -7.9-ish.
Yeah.
Renan, who would you like to call on next?
I'll do K.
Which one?
T.
Okay. What do I do with that number that we just found?
That would be
value for when we're we know our delta x, which is 25 power 6, and so we multiply. Well, after we found that, do I want to find the other 5 midpoints?
You could.
Yeah.
You could find the other 5 midpoints right away if you wanted to.
Or we could use the distance from.
There's lots of options here. I was asking what you wanted to do next.
What I do, I'd probably use I'd find the other 5 midpoints,
Okay?
and then.
What's really nice
Oh,
about
okay.
finding the other 5 midpoints, by the way?
Midpoints you can just add on 25.
Perfect. You don't have to actually go through and calculate the rest of them because all of the midpoints are evenly spaced away. They're all exactly 25.6 units away. So we can take the negative 7.9-ish number that you found and add 4.167 to it. I'm not even I'm going to stop guessing at numbers on here. I've reached the limit of me without a calculator.
Negative 3.73 repeating is what I got.
Negative
7.3.
Negative 3.73 looks like right there. Okay, so negative 3.73. That will be our next rectangle. Let's see, negative 5.83 plus 4.17. Roughly there. And what's weird is you don't actually even need to know technically where this sits because we only care about the midpoint values because the midpoint values are determining the height of the next rectangle. So negative 3.73 plus 4.167 is,
0.43.
okay, exactly. I had that one down. 0.43. 0.43 plus would be 4.467. Yes, it's loud. 4.4 plus 4.1 is 8.6-ish. Am I getting these right? Roughly. Now keep in mind, this is as difficult as it's going to get because we're purposely using numbers that weren't very nice and force you to calculate things. That's the only reason I wanted to do this example. This is as bad as it gets. So if you were gone yesterday, this probably is pretty rough. It's not that bad. So I record every day when we teach. So if you get a chance to go watch that, yeah, it's not nearly as bad as it looks what we're doing right now. Before we go any further, absolutely ask away if you want to ask any kind of questions on something that's up here first. Because we're not done, but I don't want you to wait until the end. I don't want you to get lost and then really lost by the end. Is everybody saying they're okay with what's up here so far? Okay, are you okay with the fact that we just added the 25.6 repeatedly to find the next midpoints? Because everything's evenly spaced, okay? Caden, I don't remember if you called on somebody.
Oh, no, I didn't.
Okay, excellent. Once we have the seating charts and we number them, then we can use our bingo roller again.
Ryan.
What do I do with these midpoint numbers that we found?
You don't need the midpoints, you see, you get out like how tall the rectangles are, then you already know the width.
Oh, we don't have the equation. That entire time I was waiting for somebody to tell me to pull it in the equation. Well, that was stupid.
That's what I'm asking.
That was terrible. I did this entire thing planning on having the equation up there.
It looks like x cubed plus 17.
Nope.
Um,
No, it would be nice if it were that simple. I mean, it's roughly that, but it's a cubic of some sort, probably. Well, I guess we'll just kind of estimate the heights then. But what, no, who was answering that? Was it Ryan? Yeah, what you were saying was correct. If we had an equation, I would take this number and plug it into the equation. And then that would give us the exact height, but since we don't, we're just kind of guessing. Well, then I would have made my picture a lot better if I would have known that. I was counting on plugging that number in. Okay, so roughly this one is 12. So this rectangle is, well, that marker's way too fat. Roughly this rectangle is 12 and a width of 25.6 or 4.167. Again, you can use decimals through this entire thing. The answer at the end is expected to be a decimal, so. The next rectangle looks like it's roughly a height of 20 and a width of 25.6. Now, I'm hoping you guys would understand why I would not be asking you to do a question like this on the test.
Take too long.
It would take forever. Half of your test would be just doing this one question. So because the numbers are such garbage, it would just take forever. I wanted to purposely take the time to do this terrible one together so that you guys could see how it would go or how it would be done. All the rest of the examples should go pretty fast. And even if we would have done this one with left or right hand, it still would have been much faster. If we would have gone with 5 intervals, we probably could have just done this right in our head. I wanted to do one that was bad. So this way, if nothing, you have one that's written down with information. I don't know. Anything up there that maybe you just want to ask anything about? Okay. I will. What time do we even get done?
17.
Yeah. Isn't that
12. So no. 1:18.
18.
Wait, am I reading that right?
Probably.
Yeah, 1:18. We get done at 1:18. Okay, so you guys have about 20 minutes to work. This section only has 10 questions. It's actually a pretty decent section in terms of workload.
Are we also turning this in, like in the same homework?
Yes, so now that we have the packets, I'll actually put assignments in Schoology. I didn't want to put anything in yesterday because I figured somebody would be trying to do something or turn something in even though you didn't have it. So I was waiting till you had the packets. When I put the assignments in Schoology, it'll say it's due today, but I don't go by that due date. Like, Schoology might say it's on time or late, but I don't go by that. You guys, you just need to turn everything in by the test, just like turning a packet in. I just do it this way so that I don't physically have packets in front of me.